So welcome everybody, welcome to our faculty colloquium. Today it's a great pleasure to have Professor Marek Hołyński with us, who will speak about an interplay between Polish physics and Polish computer science in the course of the last tens of years. And Professor Hołyński is really a world expert on computer graphics. He's a co-author of the well-known OpenGL standard. He developed graphical software and hardware in Silicon Valley, and he's a long-time member of the Polish Information Processing Society. Professor Hołyński, please.
Okay, good afternoon. Can you hear me well? Yes, everything works. So first of all, I have to explain where this topic came from. At the beginning of Polish computer science in late 40s and 50s, simply there were no specialists that were involved in this area. Only people who understood what's going on in this issue of machine calculating machines, electronics, were or electrical engineer. There was no electronics at that time as a field, or mathematicians or physicists. And all of the three groups contributed highly to development of Polish computer science. As you've heard, I'm not a physicist. So all of this that I'm going to talk about is somehow based on stories that I've heard from other people. Therefore, please, if you want to add something or correct, I would really appreciate it. Because 3 years ago, we celebrated the 17th anniversary of Polish computer science. And at that occasion, we started to gather all of the historical information, because before that, nobody paid too much of attention to it. We had some gaps, and there were seminars, conferences, public debates on the topic, and media asked about things. And sometimes we didn't know how to respond to it. Right now, after going through archive and recording people who witnessed these events, we have more or less a complete image of the situation. However, I realize I'm at one of the sources. Means this particular department of Warsaw University played a very important role in some of the events that I'm going to talk about. Therefore, if you remember something, or you know somebody who remembers, I would really appreciate your contribution. As I said, we know exactly when it started. It was 23rd of December, 48. There was a seminar on electronic calculating machines at the place that somehow you may recognize, Chorza 69. It was organized by Kazimierz Kuratowski, who was newly appointed director of Institute of Mathematics of Polish Academy of Sciences. He was quite renowned topologist, just returning from US from series of lectures, and he apparently saw ENIAC, the first real computer over there, and decided that he's going to talk about this machine to some of the researchers and students. As a result of it, there was a decision that we'll try to build such a machine in Poland. And the group named later Grupa Aparatów Matematycznych at this Institute of Mathematics was established. Open question is, however, did Kuratowski really saw ENIAC? ENIAC was created in 1945, but the Department of Defense, US Department of Defense, kept it secret, and they released the information about its creation a year later, for obvious reasons, because this machine was used mostly for military applications, initially for calculating ballistic trajectories for artillery, and then for research and calculations on hydrogen bomb. So it would be rather unusual if they will show it to Kuratowski, despite the fact that he was, very well-known scientist, but coming from not really friendly country. However, from the other side, Kuratowski knew John von Neumann, who, as you probably know, was very instrumental in creating this project and contributed to ENIAC a lot. Kuratowski met Neumann in Lwów because Neumann was visiting this Lwów mathematical school a couple of times in 30s previous century. You must have read books about Lwów mathematical school that often quotes a story of Neumann, at the time known and still our Hungarian friends persist that we should call him this way as Neumann Janos, to come to Lwów to convince Stefan Banach, the genius mathematician, to come to the States. Apparently he was doing it on behalf of Norbert Wiener, father of cybernetics. And the story was that he handed Banach a check with only digit 1 in it. And he said to him, you can add as many zeros as you can. And Banach proudly answered, this is too small sum for me to leave Poland. But there is also a letter written by Banach to his colleague from Lwów, Stanisław Ulam, who was quite well established at the time in scientific circle in the States, and then, as you know, participate in all of the research on thermonuclear bomb, in which Banach asked him to find him any kind of job in the States. But still, it's a nice anecdote. Anyway, did he really saw ENIAC? There is no mentioning in his memoirs of that fact. And he was very particular in writing everything he experienced in his academic career. But he mentions that he saw big calculating machine in New York, which makes sense because at that time, IBM released a really huge, but not real computer, electromechanical device for extensive calculations. And it was shown in headquarters of IBM at 590 Madison Avenue on Manhattan. It was like big windows on the ground floor and inside this machine, and people pretending that they operate on it as they used to, right? And people walking on the street, all of the people who pass by could stand there and observe what's going to happen inside. And IBM does it till that time with the new product that I think is very efficient marketing. Okay, so another question is where Kuratowski got this idea to start with computing machines. He was professionally involved, deeply involved in a series of continua and coherent sets, which were very abstract field and not directly connected to any kind of computations. And the answer to that may come from correspondence between him and Stefan Pniewski. And I'm sure I don't have to explain you who Pniewski was. I think I saw his big picture at the entrance, right? This was Pniewski? Yes, okay. Important that at that time, first of all, he was the rector of Warsaw University. And second, despite the fact that he was, creator of really very strong research centers in atomic and molecular optics here in Warsaw between the wars, he was also the Minister of Science in London government, Polish government on exile. And definitely, he must have known of all of the research that British have done on cryptography. This is what happened in Bletchley Park, Alan Turing, and how vastly it contributed to winning Second World War by Allies. And as physicist, he definitely understood it. Therefore, this letter to Kuratowski, and this letter just shows that they did talk about it, not only once. Proves that he basically, in fact, a physicist was gave the impulse to create Polish computer science. Okay, so we have this mathematical apparatuses group that's started to build its own computer. And remember that these people will just trying to make things that seem to be impossible at that time. There was no equipment, no labs, no parts, no even premises to conduct such experiments. The weather on this 23rd of December was particularly bad. It was heavy snow. So they came to the seminar at Chorza with leaky boots, and they were surviving on food parcels from UNRWA. And these guys are trying to build a machine like ENIAC. It was giant. It was 18,000 vacuum tubes. It's really commendable. And there were only 5 of them, finally, in this group. These two, only these two, Romuald Marczyński and Krystyn Bochenek, had some experience in electronics because they were fixing radios for undergrad. The rest of it has none. So there were no specialists because people who would qualify for this job or got killed or left on the West and didn't return to Poland. These two others, Leon Łukaszewicz, sitting docent Henryk Greniewski, Henio Grenio, and the third one was a technician, Michał Bochańczyk, who was the previous sergeant in British Royal Air Forces. Didn't know too much about the subject. Greniewski was logician. So for the first period of the work, they were just reading some papers. There were not too many of them because, of course, Americans weren't eager to release technical information about these computers. And trying to invent things, so they didn't have any patterns to follow. But soon they accomplished something. It took a while, actually. The first machine built by Leon Łukaszewicz is this differential equations analyzer, finished in 1953, 400 vacuum tubes. It's still, this machine is preserved at the Museum of Technology in Palace of the Culture. You could see them. You could see it, but the museum is temporarily closed for renovation. We don't know when it will open again. And apparently, that was used for practical reasons. It was not just a lab construction that is useless, right? It was for experiment. It was used for designing car bodies, planes, etc. Krystyn Bochenek created this Aral machine that also was used for some practical applications. But the major question at that time was, what kind of technology shall we use? There were two competitive, analog and digital. Arguments for analog was that people know it. People knew it because they created machines like that before. And another argument was the poor reliability of vacuum tubes. They were constantly breaking, and you had to replace them. But one broken vacuum tube stopped the entire machine for a while until you find where it is and replace it. For digital, that's obvious, right? Accuracy. If you get up in the morning and look through the window, you see the mercury in the thermometer stopping somewhere between 3 and 4 degrees Celsius. And then you go down and in a car on the digital thermometer, you see 3.7. So big difference, right? Plus, digital technology was much better in terms of accumulating errors. It doesn't allow errors to accumulate endlessly and distort the final score. But the major advantage of digital technology was that it could be programmed. If you build analog machine, you connect all of these wires and electronic components in such a way that it does what it's supposed to do, right? If it's supposed to solve differential equations, it solves differential equations and nothing else. Here, you can write program, and this general purpose machine will do what you want. And then you write another program and you do something else. It's much more efficient. So this effort to design the general purpose computer was started from the beginning, but wasn't very successful. Emal was a machine with apparently was supposed to have very good parameters, but it never worked. The reason was that when you fix one module, another module was breaking. And you fix this module, some other module was breaking, and it was endless process. Even there was a saying at the time, emal liczy niemal, proving that it wasn't easy. All of the newspapers, Problemy, Monthly at the time were talking about this as sort of intellectual challenge, right? You create a human brain. But the real problem researchers had was to make this tangle of cables and electronic components work properly for reasonable amount of time. In the beginning, it was like 5%, 3%, and the rest of it was just fixing it. There was a period when this group worked usually from 1 a.m. to 5 in the morning, because the trams that were going on the street were interfering with the calculations. And no matter what you did, this computer was wrong, right? Was not doing right things because of this interference. Later, ML2 was finished. Entire project was moved to the Instytut Badań Jądrowych in Świerk, and computational group was organized there, mostly physicists again, and it was quite productively used for designing nuclear reactors. And then ended up in Palace of the Culture and became a major computing resource of Computing Center of Polish Academy of Science. However, some of the devices that were necessary for ML were used for other projects very efficiently. Can you guess what is this? What kind of physical device is this? Okay, it's a memory. As you see, there are tubes filled with the mercury. And there's, on both ends, are electric connectors, which from one end deliver a series of zeros and ones. And this string of zeros and ones is converted into acoustic waves that slowly goes through the mercury to the end, and then again converted into electrical signals of zeros and ones. And it can go forever, right? The capacity of this memory was astonishing at the time. It was 512 40-bit words, which is over 20 kilobits. You could store like 1/5 of the page of the text. Plus, the access to this memory was immediate, right? You didn't have to wait until some device retrieves it from the memory. You just hook up to this loop and get your information. The advantage of this memory was the fact that at these ends, these ends were very difficult to seal. And as you know, the mercury fumes are not particularly healthy for people. And this was the major problem. However, according to an anecdote passed from one generation of computer scientists to another, one member of this development team realized that on the market, there are some items made of latex that are perfect to seal these endings. And he went to the pharmacy, requested 100 of these items, and saleswomen weren't particularly surprised that it was 100, but they were really taken aback when he asked for invoice to the Polish Academy of Science to this highly personal item. Okay, so emal wasn't first. Emal liczy niemal. Remember that till now. The first machine that was finished was XYZ that started running in 1958. At that time, Grupa Aparatów Matematycznych was renamed to Zakład Aparatów Matematycznych of Polish Academy of Sciences. Quite a number of people joined it. There was a lot of effort to build this machine, and under the leadership of Leon Łukaszewicz, they succeeded. And this was really breakthrough. You know, it shows the importance and the fact that we can do it. That we can really build in this country such a machine. As you see, these technical parameters are not so bad. There was a lot of publicity, presented in many magazines, and a lot of journalists coming to press conferences. And the usual question to the director was, why XYZ? And Leon used to answer, well, we started from A, B, C, and there were some other versions. And people were saying, well, it's a great joke, right? That's fantastic answer. But the fact is that they really started from ABC on a paper. And then they had some other versions and ended up with XYZ. Okay. The production version of ZAM2 of XYZ was ZAM2, first unit built in 1960. And apparently there was quite a big demand for it, you know. You could say, well, why build this machine? Who will use it? There was a line of people who wanted to do some computations from mostly public institutions, big factories, you know, these enterprises, ministries, etc. And there were some other versions. There was such a demand that this Institute of Mathematical Machinery, because then was upgraded again to got this building on Krzywieckiego 34. You may have been there, which is not far away from here. There were machines working on 3 shifts, each 8 hours, right? So it was used 24 hours a day. And I still remember the note at the entrance to the EMM that was saying it's not allowed to drink alcohol on the 3rd shift. And 3rd shift was night shift, of course. So it was somehow productive. The major push was done by Elvro factory that has its own constructions. Wrocław was sort of a natural place for this kind of enterprise because most of the mathematicians, prominent mathematicians from Lwów, moved to Wrocław. So there was a lot of trained people who could really got involved in this research. And now, as you see, there is a row of machines, right? Being tested. There's a testing room. Interestingly enough, if you notice, there are some people, this at least 2 people, who instead posing for the picture, look at some handheld devices. And I wonder what it was. They didn't have a smartphone at the time. It was 60s, right? So still one of the mysteries of the history. Another interesting story is here. At the time, people realized that building bigger and bigger machines is not the solution. That the secret is in software, right? That you can get a huge machine, but if you don't have a proper programming, you cannot do anything with it. And in order to create a programming, you have to spend hundreds of hours and employ thousands of people. So they got this idea that they will sign a contract with some company that does have software. IBM didn't want to hear about it, but there was a British firm, ICT, that agreed. And in exchange for buying 2 machines of ICT, they gave Elvro entire software. And Elvro built its own machine that was complementary to the software. So it was just reversing the situation, right? Not to build a machine and then program it, but get a software and build a machine that runs these programs. It was not only over 1,000 of applicational programs, but also the best world operating system at the time, George V, that was perfectly running on these machines. And you see this men in black have just signed a contract between Elvro and ICT. Then another part of the history is right here. Soviet intelligence managed to get the blueprints of IBM 360 series machines. They were from small to very big, right? They were compatible. Everything was running on each of them. And they divided the program for between different countries. Poland got this 32 medium range computer that Elvo was producing very successfully for quite a long time. Okay, but returning to the main track, I don't want to bother you with this technical.
We cannot hear.
The sound is off.
The voice is gone.
These noises are from me.
Teraz spróbujmy teraz.
Teraz, raz, dwa, trzy.
Teraz
Dobra.
słychać.
Okay. So we got transistors and these vacuum tubes that were not only breaking but also generating heat were eliminated. That resulted with the machines that were later called mini computers in the 70s. And as you see, I list most important constructions of this time, and with a special attention to car 65. That was machine built by the team pracowni komputerów Instytutu Fizyki Doświadczalnej for processing data on elementary particles obtained from CERN. And this machine was very effective. It was working for like 20 years without breaking. And it did perfect job. Next generation transistors replaced by integrated circuits. Again, number of different constructions. This picture is from the movie Pan Kleks w kosmosie. You may see that there was a number of these Mazovia machines in it. And interestingly enough, Mazovia was one of the few computers that had Polish keyboards. You see, there was a key EU. You didn't have to press right Alt and L to get EU. This idea was sort of abandoned because the programmers said that for them, other characters are more important than Polish characters. So it really didn't catch up, right? Now, when we had these personal computers, it was time for networks. And in fact, this development was quite reasonable and smooth, step by step in Poland. The first connection between computers, as you may know, was established in 1969 between UCLA in Los Angeles and Stanford Research Institute in Palo Alto. And 4 years later, in Krakow, they managed to have computer network based on a very powerful supercomputer Cyber 72 and 20 terminals connected to it, placed in different academic institutions. And that was a very good approach, because I remember Americans coming to Poland and saying, how did you manage that? You know, here in the States, every university has its own network and they are competing. And you have one central supercomputer and all of the universities can use this computational power. Well, one of the few advantages of totalitarian systems. And then a decade later, other centers hooked up to this network with ODRA computers working as a front end and peripherals around. And decade later, CASC, academic computer network, started to run. Now it's NASC, right? So it was very reasonable development and logical continuation of things. Important thing that was that in 1985, EARN, European Academic and Research Network, was created, which was the offspring of BitNet, just for academic institutions. And here again, we find physicists who played a major role in it. The reason for them to get access to it was that they have common projects with CERN and they have to maintain day-to-day communication, right? And here is thing that I'd like you to verify, because again, this is something that I've heard, and perhaps you may say if this was like that, or maybe some other way. This is what I told, that all of the people who had some projects with CERN were sending it or giving it on floppies to the secretary, which was created common file out of all of them, right? And in the evening, the computer center personnel was dialing a number and then transferring this file to Geneva, where the personnel was unpacking this file and shipping to individual addresses of the recipients of the email over there, with return address, one collective return address. And at the same time, during this particular session, responses from CERN were downloaded, unpacked, and printed. In the morning, secretary was giving this printout to particular people. Anybody here who can confirm that, or no? All right. So let's assume this was true, right? Also, I'd like to verify this last thing, that the director of the institute was trying not to see this activity, and the university finances complained on amount of money, because at that time telephone connections were paid, and they were quite expensive, especially international connections, right? All right, so let's leave it as it is. Another thing that, for me, especially for me, was one of the breakthroughs was donosy. Do you have any memory of donosy in this department? Officially, EARN was used for professional needs, right? But unofficially, students use it for getting in touch with their colleagues who are around the world, right? And especially sending them everyday portion of information related to what is going on in Poland. And for me, it was a revelation. Before that, I was getting newspapers from Poland after 3 weeks, 1 month, right? Or coming in an awful shape because they're transported by ships with potato and coal or something like that. And here I'm getting my morning coffee, opening computer, and I see what happened in Poland the same day. Amazing. However, at the beginning, there were some misunderstandings. There was one person who was condemned to social non-existence because somebody saw on his shelf a folder labeled Donosy. So we have network, we start with internet. First connection between Polish node of EARN and Danish node of EARN was established on July 17, 1990. On dedicated line, which was a permanent leased connection for this purpose. It was a dial-up, right? And you see the quotes from the first mail that was sent in this direct direct communication, not necessarily internet yet, right? And the network grew very quickly. All of the other centers, all of the nodes of EARN in Poland were established within a year or two. And the beginning of internet, which means first connection over TCP/IP protocol, right? Proper internet was established on August 17th, 91. And from that point, we count as the beginning of internet in Poland. However, some other people claim that there are different dates, but the most common interpretation is like this. Well, as you saw on this previous map, there was connection to Stockholm over the satellite, and this dish was located at your campus, University of Warsaw. For 3 years, served as a major Polish connection to internet. And here you have a page, first internet page on the first Polish server. Summer of 93. Your department has a Polish homepage with major facts about Poland. You should have a museum somewhere at this department to show this kind of stuff, because it's really significant. Again, I apologize for having perhaps not everything correct, because from your perspective, basically, the reason why I agreed to have this lecture is to get some confirmation from you. If all of this information that is gathered by Polish Information Processing Society on this anniversary is right, or getting some updates or additions, modifications. Okay. Okay, so perhaps, 45 minutes already passed. I guess this rest of the history, you know quite well, so there is no point of talking about it. Maybe we spend a few minutes on answering questions if there are any.
Thank you very much. So, other questions, please? I see there are some comments on chat. Maybe someone who posted something on chat would like to comment. I see there is some comment about Donosy and Xavery Stoida, who distributed it here. But maybe someone would like to, if you'd like to make a question, please write it on chat. Not the question, but just signal you're will to. And maybe as we wait, I would like to ask you about these Elvro machines. So you said there was a big interest in these machines in
Car 65?
These Elvro machines.
Oh, Elvro machines.
So who bought it? Army?
Most of it went to countries of our bloc at the time. One was bought for the United States, I guess, for obvious reasons. Because, Americans were quite active watching what happened. Mm-hmm. And recently, there are some documents, CIA archive that opened that shows that this stealing of blueprints of 360 series was arranged by CIA intentionally because they counted on clogging the inefficient Soviet industry mm-hmm. with technology that was way above their head. Mm-hmm. And they succeeded, actually. But one of the Odras was working for like 30 years on Elbrus, mm-hmm. which is, very high mountains, an observatory there. And some Odras were used for anti-missiles systems for rockets. And in this Serbian conflict, mm-hmm. This invisible plane was shot by this rocket system controlled by 20-year-old Odra. And probably the biggest success. The pilot wasn't hurt because the Odra, due to artificial intelligence, realized that this is our ally right now. Mm-hmm. So he parachuted and was picked up by special forces. But still, Serbian issued the postcard with this plane lying on the ground, saying, "Sorry, we didn't know it was invisible."
So I see there is a question from Jan Kalinowski, I guess, please.
Thank you very much for this interesting.
If I may. If you don't have a questions, I have questions.
Just a moment, but there is one. There is one from online.
This is from Jan Kalinowski. I just invited you for this very interesting colloquium. So thanks a lot for coming and giving this historical lecture. But I just wanted to add my personal reminiscence concerning Car 65. It was during the first days of martial law in Poland, when our connection to the computer at Świerk was cut with the X. And we were in the middle of the calculations with Professor Maria Krawczyk. And then we couldn't finish, so we switched to Car 65 to finish our calculations. It was in winter 82, and we succeeded. So it was a very interesting experience for me. Thanks a lot.
Thank you. So you wanted to add something?
No, I didn't hear the question.
It was just a comment about the car.
Yes, I do, if I can, because I'm trying to also at every occasion find out what people what's understanding of current notions related to informatics and computer science. Therefore, let me ask you this question. Do you know how long have we used word informatica, or which is a synonym for Polish computer science, or forever? How long have you used it? Since you finished the university or before? Well, at the beginning, the only proper term that we could use was elektroniczna technika obliczeniowa, which was direct copy from Russian, elektronная wyczислительная техника. A change took place in '68 at the first symposium on mathematical machines in Zakopane that gathered all of the people who were involved in this field in Poland, numbered 120. And the guy who proposed it was Robert Marczyński, the guy that I showed you at the beginning in this GAM group. And this was not his idea, because there was a lot of interaction at that time between Poland and France, and a number of Polish specialists were visiting France, and they got used to French saying not computer science, but l'informatique, right? This was quite natural that they implemented this word into Polish language. However, all of our scientific publications from that point were much shorter than before, because only one word instead of three. If you repeat it often enough, you get significant size paper. Okay, so this is first question. Second, since when we use word computer? Hmm?
'80s.
That's shorter. Until late '70s, we were supposed to use term elektroniczna maszyna cyfrowa. And if you said computer, I did it a couple of times in my articles. If the editor didn't change it, the censorship was changing it. And that was quite a long resistance, because I don't know why, but that all of these people who were in power were sort of objecting it. To the point when one of our friends made a joke, and he wrote an article attributing the word computer to Old Polish word komput, which of course you can find in Sienkiewicz books, right? But it meant something else. It means something similar, because it was also related to calculation, because they were computing this number of the forces that were allowed to be used, paid by the state. And he claims that he didn't, but somebody, let's say somebody, sent it to a magazine, very serious publication called Nowe Drogi. It was Communist Party official ideological publication that somehow published it. And since then we can use word computer. Some people use it like a computer for a while, right? But anyway, it went to the public circulation. Yes.
The first case in popular culture where I could locate the word computer.
Poczekaj.
So the first place where I could locate the word computer in popular culture was in the movie Miś from 1981. In this context.
But French, they still don't use the word computer.
I know.
We should teach them, no?
No, definitely.
All right. So six minutes already, right?
yes, let me just
We exceeded our time.
let me just check if there are any other questions from the online users.
No one.
So please, Barbara.
No, I'm saying no one.
No one. Okay, you say no one. Okay, so if that's it, thank you very much. Thank you for coming.
Okay.
And thank you very much.
Thank you. To pani zostawiam?